first and foremost, I'm Langdon. That's tomorrow over there. Benton is in India, so he's a little harder to see. But he'll be back in a couple of weeks, and we'll make him start teaching some of the classes after that. So everybody in the right place? Does this seem like the right course? All right. So this is my first time doing this in a long time. I haven't even taken a real class in, I don't know, 20 years, so bear with me. But I have given a lot of presentations and written a bunch of articles and a bunch of other stuff, so maybe it'll be still decent. So I want to give you a little bit of background about me. So I work for a company called Red Hat. If you're unfamiliar with us, it is unsurprising. We are actually technically owned by IBM, but the way I used to talk about it is we're a 12,000 person, something like $3 billion publicly traded, mission-driven company that nobody's ever heard of. So basically, we mostly create an operating system. We create a lot of other stuff as well, but our operating system pretty much runs, a lot of the internet. It just doesn't run a whole lot of laptops, so not a lot of people are familiar with it. But what's unusual and interesting about it is that it's open source. So all the software we sell, you can go download for free anytime you want, which is kind of an interesting and difficult business model. But we have a class, I think, in a couple of weeks about open source, so I'm not going to get into that too much. So the past few years, I worked on this project, which was trying to blow up the concept of the Linux distribution and put it back together again, which, as you might imagine, is a non-trivial exercise. So maybe we'll talk more about that at some point in the future, but it's not really relevant to this class. So BU and Red Hat have a kind of a relationship, somewhat financial, somewhat about people, and so as part of that, we embed somebody that we call an engineer in residence on campus every semester to kind of give you, the students an opportunity to kind of have somebody to talk to who's actually worked in the industry, about basically anything you want. I've had people come by and talk about their startup idea, and I've said, oh, that's terrible. Except I don't try to say that out loud, but I also talk to them about sometimes random programming problems or random problems about what a lot of this class is about, which is kind of what led to this class, which is like, what is it like to work in the industry? What are the things that you should know? And so that kind of led to this class. I refer to this as my Rasputin photo. I was giving a talk at a math conference many, many years ago, and I used to have a ponytail. So if you ever see that, that's where that comes from. All right, any questions? Feel free to talk to me. We'll get into that a little bit more. Basically, I kind of want to give an overview of what we're doing just today. So today, we're going to do a bunch of intro to the class, but then we'll actually have more class towards the end of it, or for probably, hopefully, the last 2/3. All right, so we'll be having a midterm and a final for this course, and then quizzes and assignments. They're a little bit ad hoc when we're going to do them. And if you look at the syllabus, it's got the detail, like the scoring breakdown and that kind of stuff. And then one of the things I wanted to rely on is, like, a lot of this course, somebody asked earlier, is there a textbook we should buy? Well, not really, because nobody's ever written one. So the class participation, being here for class, is kind of important to this class. So one of the major grade chunks is being in class. Speaking of, do you want to take attendance? All right, and then so there's a link to the syllabus, a link to the Piazza, and a link to the Blackboard. I assume you've all used those with other classes. Well, I know what a syllabus is. The other two I'm a little dicier on. But we'll try to get, kind of do assignments through Blackboard, I guess, and we'll do Piazza is more like for forums, so we can ask questions and try to answer them there, so that we can avoid answering the same question 47 times. I also talk very fast. If it's a problem, please let me know, either by raising your hand and saying what, or by ask me after class, whenever I have office hours. But I do know I speak very quickly, especially for people who English is not their first language. So, let's see. This is kind of roughly the structure of the class. So for the first one, that's what we're doing today, is kind of, we're just going to go through a lot of terminology because for a couple reasons. One, it's useful to know it, But then for all the rest of these topics, you already know what the words mean when we say them. The story I love about this is somebody talking about taking their first intro to computer science class and walking out of the class the first time and wondering why they were talking about like fixing clothes so much. Like, what's all this stuff about strings? Like, I don't understand. Like, so we have to remember that a lot of the times in the computer science world or in the software development world, we reuse a lot of English words and mean something kind of different. A personal example of that for me is, I'm sure most of you are familiar with the company Oracle. They had kind of a singular product, which was a database for many, many years. And it took me 10 years of using their software on a regular basis to kind of click that an Oracle is where you go for answers, right? Because it has a real English meaning. Oh my God, right? So let's see, next thing is that talk about development workflow. So one of the things that happens, we think, with a lot of people when they get into the software industry is they don't really understand like the flow of, okay, I got assigned a task. Now how do I make that task end up in production, right? So, and like I said, feel free to ask questions so you know what the word production means. If nobody raises their, if everybody doesn't raise their hand and say, yes, I know production, I'm gonna ask somebody at random. Anyone? You guys know what this means? Okay, so when you're doing software development, right, there's different stages, and we're gonna talk more about this later, but there's kind of my development environment, which is like my laptop or whatever. Then I'm gonna promote it to another environment, which is gonna be where it gets tested, and then ultimately it'll be available to external users, and that's called production. Okay, so if I say the term production, that's kind of what I mean. So getting, basically it's the workflow of how do you get your work product into some place where people can use it, so that it's actually shipping with the product, or maybe it's a public website, or whatever. All right, and then we're gonna do kind of more like a more active, you do it yourself kind of thing with the development workflow. That's what that other week is. Then we're gonna talk about work examples and kind of coding style. So one of the examples that I think is interesting and why Bendon is an interesting pairing for me is my career has been mostly in like web development, mostly back end. And the kind of code I write is very, very different from the kind of code that he writes, which has been mostly in enabling and kind of making virtualization work. So if you put our code side by side, it looks very different. Okay? As well as the quality of it is very different, the ability to change it is very different, and so what I do is actually spend a class kind of talking about, like, here's all the differences, even though we're both software engineers, right? Because that can be a really big difference in the kind of work you want to do. So that's why we'll talk about that one. And then an introduction to open source. That one we wanted to have a little earlier, but from a timing perspective, it didn't fit until there. So we'll go through what open source is, what that means, how it matters to you, and why we as a company are so invested in it. And we're going to talk about these two things. They're separated just kind of from a level perspective, but the term pattern means basically a cookbook for how to solve certain kinds of problems. And then they get labeled with like 3 to 5 words, so that, because one of the problems with computer science is words are hard, right? So we just talked about the Oracle example, we talked about the string example. So what patterns do is lets me say singleton pattern, and then you'll know what I mean by that, because both of us have read the book that describes the singleton pattern. But then we can shorthand it without me having to describe, an object that only exists once and you can dump stuff into it. So that's why we talk about patterns. The other reason we talk about it a lot too is anything, have you ever heard the term unicorn company? Okay, so in the software world, a bunch of the companies are referred to as unicorns. Red Hat is kind of one because we're an open source business model and yet we're a multi-billion-dollar company, which is pretty unusual. But so is Google, Facebook, LinkedIn, sorta. Netflix, another great example. But basically a whole bunch of companies that they're really weird and unique, and everybody wants to follow their example, but they have a whole bunch of advantages that don't trickle down. So they're sometimes jokingly referred to as unicorns. So companies that want to be unicorns, in their quest to sound cool, use patterns like crazy. If you have an interview with them, you will have to know a whole bunch of patterns, otherwise they won't think you're cool enough, whether or not you could pick up a book and learn them all in like 12 hours. So that's another reason we talk about it. Another thing, these other two we want to talk about, quality and performance engineering, because they're a little bit sideways to kind of typical software development, but they're really important, and they have very different career paths, kind of stuff you do, and those kinds of things. So we might even be able to get guest lecturers for those, so somebody who actually does quality engineering will be able to come down from Red Hat and talk about it. And then performance engineering, I'm really hopeful on that one, because that really is kind of a weird outlier. And so we want to have somebody talk about performance engineering. Then the next one is kind of my development environment. So what I want to do there is I want to both kind of show you some examples of what a development environment looks like, and then help you build one that you can use kind of going forward, because your tool chain is really, really important. So I was just talking about this earlier. In a lot of ways, writing software is like writing a book. And when you're writing a book, there's a whole bunch of things that you want to have set up beforehand so that you can concentrate on what you're doing. Because it's very easy to get distracted. It's very easy to have writer's block. There was a study done by Microsoft a whole bunch of years ago where they decided to put doors on all their software developers' offices because they discovered that somebody coming by and asking a 2-second question caused 15 minutes of them being not able to get back into their work, because they had to kind of re-engage. So Microsoft doesn't do that anymore because it costs too much money, but the idea is still probably true. And then we'll do a recap in whatever we feel like we missed, or whatever we get from you about feedback about content that you might be interested in. All right, so that's kind of what we'll cover in the classes. And so this is what today's one is about. So the first thing we're going to talk about is careers and roles, okay? And I probably don't have them all, but here's a whole bunch, and we can talk about them. All right, so software developer. A software developer is what you think of as the most obvious example of somebody who does things in the industry. I'm actually going to look at my cheat sheet, I forgot. And so, they essentially write code. There's an old joke about this too, is talking about the doors on offices, slide requirements under door, including pizza, out comes code, right? So the idea is that somebody who takes a specification for what somebody wants, right, then they type a lot, and then out it comes, okay? So that's what we think of as a software developer. This will be labeled as a software engineer, which is becoming industry standard. I still struggle with the term engineer for anything related to software, because there's a whole lot, we have rules, but a lot of times you can break them. If you took an architect in the real world and they break any of those rules, physics says that the building's going to fall down. We don't really have that problem in software, so you can get away with a lot. That's why I kind of jokingly struggle with an engineer. Yeah?
In Canada, you can't call yourself a software engineer because you need a special certification to be an engineer.
See, there you go. There you go. That's funny. I didn't know that one. So you'll see a whole mix of titles around software developer, software engineer, and variant. Okay, and then kind of one of the other challenges is that you have like an architect. So an architect is somebody who designs systems. This is what I refer to myself as. And the way I say I do my job is I wave my hands a lot, I talk a lot, and I try to convince other people that this is what they should build. And that's generally what an architect does. You will sometimes also write what we call proof of concept software, or POC software, that'll kind of show how something can work. And then a real engineer will take it over. One of my examples of this is I wrote this plugin for a piece of software called Vagrant, and I wrote it in this language called Ruby, and it worked. And I then showed it to somebody who was like a good Ruby programmer. They were so horrified that they took it over, fixed it, and now maintain it. So now it was perfect. So one of the things that I think is interesting is software developer to architect is often considered a career move, like it's an upward move to become an architect. This is one of the problems in our industry, is that we don't have a lot of, we don't have really good career paths for when you're good at something and you want to stay being good at that, okay, rather than going into something else. So An architect is a theoretical job, and a software developer is a tactical job. It is not necessarily the same people who are good at both of those things, right? I've met people who are very, very junior who are very good architects, and they're passable developers. You don't really get any architects who can at least code. But it is not really a logical progression, even though in most companies it will be treated that way. So it's something to think about where you want to be, what kind of person you are. You know, whether you want to be tactical, you want to be, or more theoretical, then you might want to think about the kind of company you want to go to and make sure they understand the kind of roles that you want to be. The other big example of that is software developers become software development managers. Architects become architect managers or become project managers. We'll talk about those in a minute. That's not necessarily a logical progression. It often pays more, but the job is often quite different. And so this is not limited to the software development world. You see this in other industries as well. You know, if you work retail and then you become a retail manager, those aren't necessarily the same job. The skills that you were good at in retail don't actually make you a good manager, right? So the same is true in the software world. Because our industry is so young, and by young I mean whatever, 50, 70 years, you know, versus say medicine, which is like thousands. We're not good at that kind of role striation, where you can kind of stay being what we call an individual contributor over time and still get like pay raises and respect and all that stuff. Red Hat is actually one of the better companies that I've seen for this, but it is a common problem. I talked a little bit about quality assurance and quality engineering. This is a little bit different than software developer in that quality assurance often involves people who are not programmers. Okay, maybe they were at some point, but they don't have to be. So this is people who test software, okay? And so, for example, my wife, when we moved to Boston, she took a contract for 3 or 4 months as a video game quality assurance person. So what did that mean she did? She played video games all day long and got paid for it. I was like, how did I fall into the wrong job? But she doesn't know how to program, right? There's no requirement for her to be able to program, to be able to test software, right? So that's distinct, and that job is usually referred to as quality assurance. If you see a job that is referred to as quality engineering, that usually means that you have to be a programmer. And so Red Hat, for example, uses a lot of quality engineering because when you want to test a low-level driver of like, you know, does the video monitor come up? Okay, you can't just turn it on and see if the video comes on. You have to actually write code that will test those problems. Okay, so they're often conflated, but they are two very different jobs. And usually either of those jobs is looked down upon by software developers. Not necessarily for good reason, but they often are. Another one, let me just see, look at my slides here real quick. Okay, so another one is the SQL engineer. And oh, sorry, I should have introduced this with, I'm kind of focused on like kind of engineering or programming jobs here. And then over here, this is kind of like people who are responsible for making things run. And then kind of over here, this is kind of making sure that software actually appears, okay? And then lastly, this is kind of about senior management that's related to software. So here, I talk about a SQL engineer. Okay, so this is, maybe can you raise your hand if you know what SQL is? Okay, so there is a programming language called structured query language that is very different from many other programming languages. So if you've heard of Ruby or Python or whatever, those are all kind of things that you would normally use to kind of program a piece of software. Whereas SQL is something that you use based on set theory to extract data from like a database, okay? So it has very different semantics than something like Ruby. So being really good as a SQL engineer, and so therefore generally pretty good at set theory, is very different than being able to say, hey, do this 5,000 times, okay? So SQL engineers tend to kind of striate out. Usually they start in some kind of job like this, and then for whatever reason they get really into SQL, and so they start being really good at it, and then they get paid more to do that because it's a rare skill, and then they fall into it, and then they hate their lives. Sorry, I'm not a big fan of SQL. But you will see SQL engineers. This is a relatively new term. because we'll talk about database administrators a little bit later, but this job and this job are often conflated by people, okay? Even though what this is, and we'll jump ahead a little bit, database administrator is somebody who's really into the deep, dark bowels of making a database run as optimally as possible. All right, raise your hand if you know what a database is. Okay, trying to gauge room, so it's a little bit tough. Okay, so when I have a piece of software, right, I often want to store information somewhere. So for example, Facebook, it knows everything about you, whether you have a Facebook account or not, okay? The way they store that information is that every time you do something that interacts with Facebook, for example, I just was reading an article by the EFF, if you have a Ring doorbell, you know, one of those electric doorbells, every time you open the Ring app, it actually sends your location data and what's going on with your Ring doorbell to Facebook. And so Facebook just files it away and says, hey, this unique identifier, and then eventually, now they have this big, huge block of data. Well, you want to structure that somehow, right? Because otherwise it would just be sitting there. And that's where something like SQL comes involved, or there's lots of other alternative databases as well. But that's basically where you store your data. And now that I say that, and you guys not being a whole lot of awareness of that, maybe we'll add data lakes and data marts and a bunch of other things like that to this course, but maybe not for today. All right, so that's SQL and databases. So let's talk a little bit about a support engineer. A support engineer this is another one that kind of has this quality assurance, quality engineering problem. Support engineers tend to be looked down upon by other people in the industry. So this could be somebody who is as simple as like a customer service rep at a software company, and basically they just kind of take complaints, okay? But in a place like Red Hat or other kind of deeper, scarier software, this will be somebody who is actually an engineer, because what they'll do is actually work with the customer or whatever to actually write software that will replicate the problem they're having, okay? So that's why it's an actual programming job when you see it as support engineer versus there's not a lot of good terms for people who are more just kind of taking problem statements, except for just support. Some companies, in a way to try to balance out those stereotypes across the different organizations, will actually force their software developers to spend, say, a week every couple of months working in support, okay, or working in quality. Google actually does a really interesting thing where if I write a piece of software, or me and my team, we're actually responsible for responding to any page, like anytime it goes down or anything else, for 6 months until the number of times it has issues drops below a certain threshold. And then their regular old support people kind of take it over. But if it goes back up over a threshold, it actually goes back to the development team. Okay? So in that way, they're trying to balance some of those relationship problems you have between what people see as higher order, versus lower order engineers. The last one I bring up is kind of like a SQL engineer, a network engineer, or a network architect. The reason this is special is because it's hard and esoteric. So, as you all know, you have Wi-Fi, for example, or you might have a hardline cable. But in order to make all the different computers be able to talk to each other in particular ways, there's often lots of mechanics involved in saying this computer can talk to that computer, which can talk to the outside world. These can be incredibly complex. It's a big security nightmare as well, right? Because you want to make sure that this super secret computer that should only be accessed internally can't be seen by the public. So that's why it kind of ends up with its own class of kind of engineer, as well as the tools that are involved. Cisco routers, a bunch of other brand names, all have their own programming languages, their own style of doing things, and so it's kind of really esoteric knowledge. All right, moving on to okay, so these are all the people who make stuff, okay, generally speaking. These are the people who make sure that stuff continues to run. Okay, so, when was the last time you went to, say, Facebook and you couldn't get to it, right? How often is it down? Like 0 ever, right? And they spend a lot of time and a lot of money and a lot of people to make that true. There was actually a really good example of this with Netflix a few years ago. all of Netflix, you know, they run video, right? But all of it is actually running on hardware that they don't own. It's running on computers in what's referred to as the cloud. And there was a major outage in Amazon's cloud, part of it. And because of how these people did their jobs, they didn't have an outage. It just moved to other clouds and elsewhere in the cloud. And as far as users were concerned, they might have gotten a glitch. You know, they might have gotten a second of the TV show they were watching not come through, but it just worked, okay? So traditionally, these are the two jobs that you see in this making things stay upright. System administrators and database administrators. System administrators are responsible for making sure the computers are there, making sure the software is deployed on them, making sure they're, to some extent, are up to date, making sure they're secure, or writing tools to do so. Database administrators, again, deep, dark, secret magic of databases, know how to do that, make sure they stay upright, make sure they're as optimally fast as possible. But both of these jobs are sometimes referred to as, they're people who fix the cake. Okay, so, you know, you bake a cake, right, and then you put the frosting on it or whatever, and then you get to the end of it and you discover that, you know, it doesn't taste as good as you wanted. So you just cover it in sugar and then serve it anyway, right? Site reliability engineering is something that has started to take hold in the last, I don't know, let's call it 5 years. Usually referred to as an SRE. And what they're referred to as is they fix the recipe. So instead of fixing it after the fact, you know, and making sure it comes back, okay, so, you know, the computer fell over or whatever, they fix the recipe. So they try to make sure that the pipeline that is producing the software and displaying it to end users gets fixed so that it doesn't happen again, okay? So the system administrator traditionally is reactive, and whereas the site reliability engineer is more prescriptive. Does that make sense? Okay. And it took a long time to get here. There was a Google guy that actually wrote a book called Site Reliability Engineering that I highly recommend if anything in that space sounds interesting. Okay, so these are the people who kind of make the projects go, okay? So when you are doing, as a software developer, I can't be an expert in all the other fields, right? So me personally, I worked a lot in financial services, I worked a lot in pharmaceutical, but I don't know, I mean, I do now know a whole lot about financial services, but when I started, I didn't really. I also don't know a whole lot about how pharmaceuticals, like basically I work mostly in research and sales, okay? So for example, in pharmaceutical, when they want to change the price of a drug in France, they actually do an analysis of the price of that drug in Germany, and to figure out how many people will drive across the border to buy it in France, okay? Never even occurred to me that this would happen. So what we do to solve that problem is we have various kinds of analysts, okay? So people who really know that business. There will also be another class here that I enlist called an SME, which is a subject matter expert. They'll be attached to a project who will provide that like business knowledge, whatever it is, to the software engineering, because I can't learn it all. So, you know, I need experts to be able to ask questions. But then we also have these kind of top three. Product management, that is this idea of people who interface with customers, okay? And they have an idea of what that product looks like to our end users, whatever they are. Again, I could learn this as a software developer, and in the past I often had to, but there's only so much I can do. So that person's primary job role is to understand what's going on in the marketplace, how our software fits into that marketplace, right? Because there will always be competitors. And then what we should do to continue to dominate that marketplace or grow that marketplace, whatever it is. So that's what product management is. The particularly fun thing about these three is that they will be referred to as PM everywhere. All three of them indiscriminately, and you have to figure out in any given organization which one's which. For example, we call these product managers, and we call these PMMs, just for an extra M, because everybody needs more M, and we don't really have a whole lot of project managers. So a project manager is somebody who is responsible for making the project go. So they're the one who kind of sets up the schedule, sets up the deadlines, and then makes sure that the software engineers who are delivering on it are actually meeting those dates. You know, they're checking boxes and making sure that you know, upper management knows what they're doing and how fast it's going to deliver, etc. Right? How are we doing on time? What time is it supposed to be? No? Anybody remember? 2:15?
2:15.
All right, so 20 minutes? All right. I'm not going fast enough, apparently. All right, so program management. A lot of times with software, it's actually a lot of different projects that have to come together into one project, or one like product, right? So we deliver something that is an operating system. So you might imagine there's not, a team of 5 people who build an operating system. They build all the different pieces, but whenever we want to do a release, right, we need all those pieces to be done at basically the same time, otherwise we can't do a release. So that's what program management is kind of that overarching understanding of like, okay, we have all these different projects, let's make sure they go together and release. This will also be sometimes called portfolio management, depending on the company and how much McKinsey they've done. All right, CXO. So the X here is for technology or information or security. There's a lot of other X's that fill in. E, for example, is a pretty common one. O, another common one. But I wanted to kind of talk about the different roles. So a CTO typically is the person who leads the engineering team. Okay, they may also lead quality and that kind of stuff, but they're a deep tech person, right? And they are kind of the expert in the technology that the overall organization does. Whereas a CIO is the person who's more about delivering software within an organization. So if you run a big bank, your primary business isn't software per se, but everybody needs a computer, everybody needs mail, all that stuff. That's what a CIO would do. So they tend to be a little bit more management focused. They often can be also deeply technical, but their job role is more about delivering software inside an organization rather than leading up the work that you do. And then you'll often have, at these days, you'll have somebody who is a SO or a security officer, and this person has an overarching responsibility on making sure that you don't have Facebook data breaches, right? And so they usually have such a high title so that they can go talk to anybody in this pipe and say, no, you must do this, because otherwise it won't be secure, right? Does that make sense? All right. Anybody have any questions? All this stuff makes sense? Interesting, I hope. All right. All right, next. So we were going to try to do this. Hopefully, I don't know, we have time? So what I want to do was just kind of give you guys a minute, okay, and break up into groups. So let's just do like maybe with you right there, and the 4 of you over there, and then you 3 here, and then I don't know where you want to sit. Do you want to be in this group, or so maybe you guys together, and then maybe y'all together here, okay? So, and then starting on this side of the room, you guys are the software engineer, then site reliability, then chief technology officer, that'll be fun. Project manager, and then, oh, sorry, wait, is that it? 1, 2, 3, 4. Okay, so we have 4. So the last group can pick project manager or architect, it's up to you. So the idea is, come up with a set of questions that you would ask a person who is interviewing for that job, okay? Then the assignment is, come up with some answers, but you're not going to turn the answers in. I'm going to ask you the questions next class, and I'm going to pick people at random, and I'm going to say, you, software architect, you want to be a software architect, and then I'm going to take one of the questions, and then you're going to tell me the answer. All right? This should be insane. So spend a few minutes now, so that you can get to know your little group or whatever, and try to come up with some questions. Just write them down, and then you're going to tell them how to submit them online somehow, because that's beyond me at this point. All right? Go. Yeah. Okay. Yeah. Or yeah. Okay.
So last class we answered so we didn't know
Okay, so what are some questions that you would ask?
Okay, I should ask you position a little bit.
Yes, the ball.
I think this is general.
portion of the interview list. Alright? And that probably puts it on me to publish the questions before that. This is mildly me making it up as I go along. Alright, you guys get it? You know what's going on? Alright, tell me one of your questions.
Well, I was thinking at first, like, how would you problem solving, like, how would you deal with the problem, or how would you fix it, or how to fix the problem?
Cool. That's good. It's actually a whole interview style called compensates.
Like,
360 style or something like that. That's a whole interview. Or no, sorry,
something, tell me.
so that's pretty good. But see if you can also think of at least one or two that are a little bit more specific to this job. You know? Good? Alright, give me one of your questions.
So we're doing project management. So
Okay.
our first question was, how would you approach someone who missed a duty CSS?
Haha, good one. Beat them. That's the answer, right? Hit them with sticks. Good. Tell me one of your questions. So that's what's tough with the CTO, right? Is that
Dictatorship?
Yeah.
something like that. Good question might be something along the lines of, talking about an issue that change how your engineering population works, right? So it's got to be strategic. As I said to my mother when she first got her first strategic job, she said yes. Right? Because a strategic job is about what you do, nothing to do with what you do today. So think of other job or questions like that.
I feel like that's not necessarily true.
Describe an experience you had meeting with that team on a large scale.
I'm gonna be passing around a sign-in sheet for attendance. Put your name and BUID.
What was it you do? Misplan, / made a mistake as a I think we can also maybe ask like.
No, just do something, and then she'll make sure. Yeah.
Sometimes, usually, so
Like
yeah,
what would you
so
do if one
maybe
of your
they're
members-
regularly running out of space on their hard drives or something, or they're progressively just deploying, right? So maybe they
What would
have
you
a
do
script that is
if
constantly
there
running
was
on
a
the
situation
hard,
in
the hard
which
disk or
one of your
hardware,
members
but you know, so that the next time they'll know in advance before they get started. That's the idea, is like fix the rest of the cable. Alright, I can only give you like 30 seconds more, and I think I'm still gonna run out of time.
Management style, yes.
Describe your ideal management style.
Yeah. And we also need to know the Yeah.
Stephanie, are you doing project manager?
CPO.
Oh,
Okay.
Alright, time's up. Gotta keep going.
What's your
We should make this class longer, or me should talk less. Alright, so moving on to general terminology. So this is very, very common to see people refer to the, I can't even say it, abilities or ilities. So this is like reliability, sustainability, I don't know, there's like 1,000 other ones. But if you see, basically what I want to show here is not the list as much as to say, if you see either of these things, you'll mostly hear it. What they're talking about is that laundry list of the kinds of characteristics that you want your software to have, okay? And in any given context, so it's perfectly legitimate to ask which of those you want it to have, but that's what that slang term means. And in my experience, it comes up a lot. So you want to have a little bit of background. I18N and L10N, okay? Software developers are wicked lazy. Okay, so I18N means I, then 18 characters, then N. Because if I had to write 18 characters, that would be too much work. And this is L, and then 10 characters, and then N. You'll see Kubernetes does this as well. It's K8S, or Kates. So this is internationalization. This is localization. Okay? So the difference between those two things is also useful. So internationalization is the idea of making something internationally accessible. Okay? So maybe compliance with local law or whatever. Localization is making it actually consumable by a different culture. Okay, so one of the great examples I had about this a million years ago was that if you are writing a piece of software and you have like an admin function, in American culture, you hide it. In many Asian cultures, putting it there but not allowing access to it is better. It actually is reassuring in that culture to know that there are people with power who can control things. So. Very bizarre, right? Like there's two totally different cultural things about whether or not you should put something on the screen. So that's localization. Auth squared, okay, again, too lazy to type it out, is authentication and authorization. Authentication is like your username and password, and then authorization is the functionality to say, can you get to this feature or that feature? Okay, it might be related to like, you know, whether you paid or not, but it might also be like an admin function versus a non-admin function. Oh, I put this twice. Okay, Devops. This is a weird one, probably worth a whole class on its own, but this is the idea that we're developers and operators. So when I say operators, I mean like sysadmins and site reliability. Developers, I mean that whole engineering bucket. If you make them the same people, do you get better results? Many people think yes. And so my Google example I gave earlier, where I kind of said, hey, you actually have to operate this in production for a while. That's an example of DevOps, where the developer is also responsible for running the thing. Because who best to respond to problems with it aside from the developer, right? But at the flip side, as a developer, do I really want to get woken up at 2 in the morning because something went down? Not really. I'd much rather just hand it off. But it is true that I'll be more likely to write more robust code if I don't get woken up at 2 in the morning every time it goes down, right? So lean is a manufacturing technique from Toyota for cars primarily, from the 80s, I want to say they started it. And a lot of software engineering has started to follow that model. And DevOps is one of those outcomes, so is Agile, which we'll talk about later. TDD and BDD, so this is test-driven design and behavior-driven design. TDD is basically the idea that if you write a test for the thing that you want to code first, and then write the code, you'll have better outcomes. And you'll write either less code, or you'll write more robust code if you write all the things that you want the code to do before you write the code to do it. Okay, so that's test-driven design. And then BDD kind of takes another step back and says, what behaviors do you want the code to produce, and then write the code. Okay, so they might be, so it might be like you write a behavior which then results in tests, which then results in code, but it can also be directly behavior to code. Okay, so just kind of getting through some terminology, we'll do some actually stronger examples of TDD. BDD is way less common, so it's better to focus on TDD at this point. LAMP, mean, MERN. Okay, so LAMP is the old school one, which is basically how do you run a website? Linux, Apache, MySQL, and PHP. Okay, it's an acronym. All right. Mean is Mongo, Express, Apache. Mongo, Express, Angular, and Nginx. Okay, so you see these floating around all over the place. You just kind of have to look them up or remember them. But basically, they're a combination of tools that you use to run some sort of website. 99.9% of the time. And I would say probably Mean and MERN are the most popular ones right now, but they kind of like, fluctuate over time, and you just kind of have to keep track. Orchestration, the reason I bring this term up, because a lot of people don't know this. I'm not sure if they don't know the English word or if they just don't know how to apply computer science, but when I have a vast farm of computers running a piece of software, so I have 16 databases, 3 different web servers, a whole bunch of caching servers, and then routers and all this other stuff, they all have to work together to actually deliver the application, right? that activity of making them work together is called orchestration. Okay? You'll also see this one nicely shortened sometimes with some, whatever the number is that fits in there. But it's less common. What we're not going to talk about in this class, but is also super hot right now, you can go look it up on your own if you want to, machine learning, which is basically glorified statistics, although often referred to as artificial intelligence. Blockchain, which is basically a way to prove what's called a ledger. So in other words, to say, so have you ever played the game Telephone as kids? Basically, I whisper a secret in your ear, and then you whisper the secret in their ear, and then them, and then them, and then you find out what it turned into at the end. Problem with that, right, is basically it's lossy, right? It changes as you pass it through people. What blockchain does is it lets you attest that this thing was said by this person at this time, and then the next person, and the next person, or whatever, and prove mathematically that they're all connected and that there was a chain, loosely. There's a lot more to it than that. A really good example of this, which is an actual real use case versus the buzzword it normally is actually relevant to y'all. If you're applying to grad school, how can you attest that your transcript actually came from BU? Blockchain is a way to do that, okay? So that you can have a copy of it all the time that you want to send to any grad school in the future, and you can attest that it actually came from BU originally. Digitally, obviously, if you have a thing with a big seal on it, makes it easier. Big data related to machine learning. Big data is basically you have vast amounts of data now. Remember I was giving the example of Ring with Facebook? Like, what are they going to do with that? Do you know how much information that is? All right, so there's an old South Park episode. You should go look it up, okay? Where basically they go and collect underpants, okay? Then they're not sure what, then profit, okay? This is the idea of big data. We collect all the information we possibly can, and we store it, because at some point in the future, we might figure out an algorithm that we can make money from, okay? So, in the South Park episode, they think underpants are the important thing. It is hilarious, so I recommend it. Probably offensive. Distributed computing. Okay, this is another huge topic, but traditionally, we've basically been trying to do the same thing in different ways since the start of the industry. And I could go back before this, but it'll really get irrelevant. So in the early days of like my career, so like mid-90s, comm and decom, okay, were a big thing out of Microsoft. This was a way of doing distributed applications. Okay, so one application could talk to another application on another computer and present one unified face to the end user. Corba, a reiteration of the same thing, slightly refined, way impossible for anyone to use. And then next, service-oriented architectures, also pretty good. One of the big things these all had in common were they were very top-down. So you had a whole bunch of really smart architects who would describe the entire system and then give a whole bunch of engineers pieces of it to build. What's the problem with that? It takes months, if not years, to describe the whole thing, and then months, if not years, to actually deliver all the pieces. And on top of that, so not only does it take a long time, right, with no material progress, you, as the architects, have to think of every scenario, not the ones that will actually happen, okay? So that's why most of these mechanisms have fallen by the wayside. And grid is actually on the next slide too, is basically another distributed model, but it bridges the gap a little bit, okay? But basically this is the idea of using vast resources of disparate computers or systems or whatever to come together to deliver something. Have any of you heard of the SETI project? You raise your hand? Okay, so super popular app that you would run on your computer or whatever as a screensaver was to search for extraterrestrials in a distributed way. And so they needed a piece of software they could put on any computer, right? Because any idiot wanted to download it as a screensaver, and they literally helped searching for extraterrestrials in space, right, in astronomy. There's a bunch of other examples. There's a protein folding one that's really interesting. Basically, I think it's about cancer research. There's been some actually really big wins there that does the same kind of thing. But now there's also like mobile phone, like screensaver essentially. So when you're not using your phone, it'll run these processes in the background. So that's what grid's really interesting for. Cloud, you know, one of my favorite quotes. You'll hear this all over the place. It's just somebody else's computer. But basically the idea is like, I don't own my own hardware. I want to go and just rent it from somewhere, okay? And so that's what clouds are doing.
It's 2:15.
Okay. Oh my God, there's like slides and slides left. All right, so let me finish this slide and then maybe we'll pass the rest of them on to next week. Microservices. So microservices and serverless, are really good examples of the opposite of the prior, which is let's just develop each individual piece of functionality that we need at a time, okay? So that we don't take that top-down approach, and instead we say, oh, I need a service that will do a stock trade, or I need a service that will let somebody choose to do a stock trade, right? Or I need a service that will do blah, and then I hook them all together, but I write them in such a way that they can easily hook together, okay? That's what microservices really is. Serverless actually takes it one step further and just says, I'm not going to care about anything involved except for that one little tiny function of like trading a stock. And then I'm going to hook it in to my systems for wherever I need that. You know, a trading desk, but maybe it's also on you know, a currency exchange or whatever, so that you have this one piece of functionality that you can hook into lots and lots of other places. So again, we're just trying to get a terminology overview. You know, hopefully this is helpful. And I don't know, we'll see you next week, I guess. So just a reminder, the assignment is publish the questions you came up with, okay? We then review the questions of everybody else before the next class. We'll send out a note or something about when the timing is. And then when we do the next class, I will point at people randomly, tell you what job you're applying for, and ask you a question, and we will see if you can answer it. And that should entertain me at least. So
Only one person needs to submit as long as everyone's name is at the top of the sheet.
Where are we submitting?
On Blackboard.
Oh,
Yes. And yeah, also make sure you guys sign up for Piazza.
any other questions before everybody leaves?
Also, did everyone sign up? Or sign in?
we're down to also in it. Oh yeah. Do we have to write?
Oh, and also I have office hours on Wednesday afternoons, like basically right after this. So if you guys need anything, you have